Good day, everyone. My name is Lourens Leeuwner from the Endangered Wildlife Trust. I manage the Wildlife and Energy Program. This project, a remotely piloted aircraft system for marking live power lines, was executed by the Eskom EWT Strategic Partnership and funded by Eskom Research. We know from 26 years of data with Eskom collecting all the incidents that we have on power lines in South Africa that avian collisions form a large portion of those incidents. We also know that there are mitigation measures available, and we found through other research projects that attaching line markers to power line cables is one of the most practical reactive methods of preventing bird collisions. Current methods include the installation by hand using a link stick from ground level on live lines, and also be installed from a helicopter. Obviously, it's quite a costly and dangerous method. And then also live line trucks, bucket trucks can be used to install. So again, for Eskom, the big issue was human safety and also cost. The solution we proposed through this project is to use drones or remotely piloted aircraft systems to lift the flappers up to the conductor and then to just attach it remotely. There are a couple of challenges with this project. Firstly, the type of bird marker, the type of flapper that we used had to be approved already in the Eskom system. There's also live line criteria with Eskom, including their sort of minimum clearances and working on a live conductors. And then there's the requirements from the South African Civil Aviation Authority to actually operate a drone commercially in South Africa in any airspace. Looking at the bird flapper, this is the one that we settled on. It has a sort of a sprung clamp, which can fit a variety of conductor and shield wires, already approved by Eskom as to not damage the conductor. They're happy with the wind loading and snow loading characteristics as well. So we designed the system around this device. Here's what it looked like when we 3D printed one of the first versions of it. We wanted the mechanism to hold at least 4 flappers, which would prevent the situation whereby you land the drone repeatedly to attach a new bird flight diverter or flapper to the device, as this would waste battery. And with drones, battery is actually a big deal. You only have so many flight packs with you in the field, and you might not always be able to charge them up. From the CAA side, a category 2A drone weighs less than 20 kilograms. Anything over that, you have really a lot of hoops to jump through, if you can say it like that. So the entire payload needed to be lighter than 20 kilograms. We also wanted to be able to attach it to a drone that you can just buy off the shelf, and then you can go ahead and attach that mechanism and the work can be executed. These are the 2 platforms that we settled on. The DJI Matrice 600, which is used quite extensively in the film industry, and then the DJI S1000, the octocopter, which we used only during development phase and we're not currently using anymore. The other thing was magnetic interference from the power lines and how this would actually affect the aircraft. That was very important criteria. And then all the certification from the CAA, you can see on the left there, the process we went through started in September 2016, when we actually had the first pilot license to fly a drone. But that doesn't mean we could go ahead with the project. There was still the certificate of registration for the drone, the air service license, the type approval for the communication of the ground station, the airband radio needed to be licensed as well, and then a letter of approval with a safety case for the drone, and finally the ROC, which is our operating certificate, which is the final step, which we obtained in January 2021. This gave us lots of time to design the system because we didn't need time. There were many sort of iterations. This was one of the first prints that we did. You can see it's quite weak, and there's no safety clearance between the drone and the mechanism at this stage. It then looked something like this with a bit of a cardboard box and some conduit. The device at this time was also dubbed Sputnik because of the way that it looked. Just those pipes were basically there to help guide the mechanism onto the cable and then to release the bird flapper. We tried with a long piece of string because of the safety clearances that Eskom had given us initially, and realized that this was not going to work because of the pendulum effect. We then also 3D printed the device to sort of make it smaller, more compact. Looked something like that. At this point, it was only able to hold 2 bird flight diverters, so we still had to work on it to make it hold 4. And then we realized when we're up in the air, we also need to see the device, so we installed an additional first-person view system with some goggles as well, so you need an assistant on the ground with the pilot to help guide the mechanism. And this is also when we introduced the link stick, which is that orange stick, an isolated stick that's already used in the industry to attach mitigation devices to live power lines. So basically, yes, it was design, test, and redesign. There's Matt, one of our pilots, just testing on a normal sort of nylon rope just to see the release mechanism, if it releases easily. That was one of the challenges, to get the flappers to actually release. And we also had some assistance from our other team members. Lots of safety considerations and lots of paperwork to go with this. You can see how it is designed here. The aircraft needed to be able to land with the mechanism as well. And that's where this swivel mechanism at the bottom comes into play to allow the pilot to set it down on the ground and also to take off with all the flappers installed on the release mechanism. There you can see it in action, really just on a sample. It's not a live power line. That is just a dummy line that we strung in between some trees because we didn't have clearance at this point yet to fly on a live power line. The next step was actually to test the electromagnetic fields on the drone. This was a big question from Eskom's side. They didn't want us to fly up to their hardware and then the aircraft falls out of the sky and onto the conductors, obviously. So we went to one of their testing facilities and had some of their engineers assist us with this experiment. Here we set up an artificial electromagnetic field and we flew the drone around all these different situations, which was controlled from the office, from the sort of control center inside the facility. They could change the voltage and they could change the intensity of the magnetic fields. And then they drew up a very nice report for us to see, in conjunction, obviously, with what the pilot was experiencing, to see the effect on the drone and the potential effect on the mechanism itself. This was roughly the result that we came up with. It basically showed that there is some magnetic field or interference that's picked up by the drone, but it doesn't affect the operation. There is a warning on the system that there is some magnetic interference at higher voltages. But very important was that the Sputnik device, as it was called then, could actually hold a charge of up to 36 kilovolt, and that it had to be protected. It basically had to be separated from the drone. On to 2021, the CAA finally approved our application for a ROC, or operator certificate, and this was when the auditors came to site to do the inspections on our operations. We also had to demonstrate to them what we were trying to do, because this had not been done in South Africa before. So they looked at everything. They looked at our ground station setup, our paperwork, but also at the actual mechanism. And they asked a lot of questions about landing safely and taking off and dispensing objects. So for them, it was, because it's a new thing, they really interrogated it. But we successfully demonstrated to them in the field. And we just, again, strung a cable, not a live cable, just a cable in between trees to explain the concept to them. So from their point of view, they were happy with what we were doing. And then we went on to Eskom's Voltari Coaching Center, which is a testing center where liveline personnel actually train to work on live power lines. So we also learned that all of the payloads that we use need to be tested and checked as well and approved before you can fly. So we flew under supervision on a live power line here for the first time in controlled conditions. So the line is live, but it's not connected to any end users. So if there's an error, a pilot error, or if there's a line trip, it wouldn't be such a big deal. But it actually went off without a hitch. The Eskom guys were there on standby, also assisting us to remove the devices from the line again. And in this photo, you can see that we actually placed the line marking device in between two live phases quite closely, and it had no effect. So this was considered, this experiment was considered a success. And is everyone very happy and successful? And then onto the live line field trial after that. So with the results of that, of the activities on that day, we could then motivate to trial this in the field. And we again had to set up in the field with generators because it was quite remote and we had quite a lot of work to do. We wanted to be able to charge the battery packs in field. This was the line in question. There'd been some collisions of vultures. We had an Eskom truck there marking a section of the line while we were at the same time marking the line using the drone, just so that we can time the, basically look at the effect of it, how long does it take, how long does the truck take, and how long does it take us, and then we could do the cost comparison. Here we are in the field then, completing the work. Safety officer always on standby, looking, overseeing the operations. And there you can see the FPV goggles on the top right for the pilot's assistant to help guide the mechanism onto the line. Here's a close-up view. And a short video just to explain how it works. You can see in principle that the whole mechanism will actually make contact with the cable first, and then with an upward throttle from the pilot, that upward response then causes the flapper to attach and remain on the line. You can see it there again. There we go. All right, so what is the cost benefit at the end of the day? When comparing the RPAS to the bucket truck over marking 1 kilometer of line, which is approximately 190 flappers, you can see a 40% savings in time. And that's because the bucket truck has to set up and has to keep moving along. It takes quite long to set up the truck and do all the earthing and do all the insulation, all the safety checks. That's really where the time is wasted. And then in terms of cost, there's a 41% saving in cost as well. When comparing this method to a helicopter marking 1 kilometer of power line, the helicopter is much faster. It actually takes 81% longer to use the drone. However, there's a cost saving of 92%, which is quite significant. So if you're willing to spend a little bit more time, then you can save a lot more money. So this is just talking about cost. It's difficult to measure the actual safety benefit. Of course, you completely remove the safety risk if someone is not on the skid of a helicopter. So that's really, for Eskom, was very important outcome of the project. And yeah, that's where we are now. But what's next for us? We need to test the system on a transmission line, which we are in talks with Eskom on marking a transmission line shield wire. And we also want to improve the overall effectiveness of the system by perhaps designing a system which can hold more bird flight diverters, maybe make it a little bit lighter, so to optimize the flight time of the drone as well. But for now, the project is closed with Eskom Research. We're just looking for opportunities to implement it across the country, but also internationally. And a big thanks to Eskom Holdings for making this project possible. Also Preformed Line Products, who sponsored the devices that we used in the experiment. NETFA, the training facility, and all the staff at Pultari Coaching Center who assisted with the project. Thank you.